This demonstration of context trees involves a message flow that interacts with GitHub and Jira. We've got a GitHub input node that triggers the message flow, and the aim of the Jira request node that follows is to push the same information into a new issue. We then have a log node and finally a Slack request node whose purpose is to let us know what the flow has been up to. And thinking about the data structure that's passed into the Jira request node, when we enter into the discovery process and start looking at the individual fields that have been mapped across with Jira, we know we're going to need to take information from the GitHub data structure that's been passed out of the input node. You can see here we're going to interact with the Jira bug tracking project. We're going to create a Jira bug, and the summary of that bug is being taken from the title of the GitHub issue. And again, the windows here, the hierarchies, allow us to navigate through those data structures. In the description field, I've added some more text, which again takes the issue number, but also the issue description from the GitHub data structure, and then uses that within the context of what we put into Jira. Now, so far, that's relatively simple. We've just taken data from Git and put it into Jira. But when we hit the next node on the flow, and this is an example of a log node, we actually want access to two different data structures. The information that we're logging here is not just the GitHub issue number, but also the issue ID that's just been created inside of Jira. So we now have two different pieces of data coming from two different interactions that have occurred earlier in the flow. And in a similar vein, if we go to the Slack request node, the last node in the flow, in the Slack message that we want to put into a channel, we are also taking two pieces of information, the Git information and the Jira information. Now, in a traditional message flow within Toolkit, we would be responsible for copying that data forward. But in this case, when we put it into recording mode, you can see that the flow is very straightforward. I've not had to do any configuration or further bespoke coding to ensure that those data structures are passed through correctly. Switching to the web browser, we're going to try out this flow now. So I'm going to create an issue in GitHub, which I'll give a convenient and easily recognizable title, so that in a moment when we look in Jira, we'll be able to see it. So this is Ben's fabulous demonstration issue. And again, for the sake of a good description here, I'm just going to put in some free-form text that we should see reproduced in our logs and our Slack message later on. And again, this description field should get copied over into the Jira issue when it's created. So it clicks create there on the issue, and you can note that it's number 14 in GitHub. We'll see that number appear as we go through the other systems. Now at this point, the issue hasn't arrived in Jira, so we have to remember that the polling interval for GitHub is up to 1 minute, so it can take a moment or two. So coming back in the toolkit here, we haven't yet retrieved any data, and we could sit and wait for a minute. But what we can also do while we wait is actually go into the web user interface and check on progress there too. If we navigate into the message flow, I can go to the activity log view, fetch the activity log, and then see if it's come back yet. And sure enough, in the few seconds it's taken us to navigate into the web UI here, I can now see entries saying that the ACE message flow has been triggered by the creation of that Git issue number 14, and we've then replicated the data over to Jira. And we've got both of those bespoke fields being captured as tags on that log entry, so the flow has done its job. So if I come back into Jira and refresh, we should then see the issue is created in Jira too. And sure enough, there it is. Ben's fabulous demonstration issue, and if we click into it, you can see that the description has been copied over too. So a relatively trivial example, but really the important thing here is how the actual coding experience was within ACE. Just for completeness, we can see that the Slack entry has been made there as well, and again we've carried those two pieces of data into Slack. At this point, what we're going to do is then also do a little bit of extra development. So if we just take the flow out of recording mode, we're now going to wire up an extra few nodes. And the purpose here is to show how the tree structures of the context tree that we've been interacting with here apply in a traditional developer's situation as well. So we've got a trace node here where I'm tracing this new tree type. I'm tracing the context tree into this trace field. And again, we don't want to leave our compute node users behind. So if I go into my compute node ESQL, what I also have here is an input tree, which is immutable, that describes those prior inputs from the earlier nodes in the flow. And I can then refer to them, and I can use content assist to help me do that. So I've typed in context, I've put a dot character, and the control space key on my keyboard is enabling me to select nodes, and then I can choose the prior node in the flow which is sending its data structure into this piece of ESQL. Now, in this case, what we're going to be copying into our output data is, again, a piece of information both from Git and from Jira and also from Slack. So we've got 3 different data structures that are all part of that context tree that have arrived at the compute node part of the flow. So if we make some saves on what we've just done there and then redeploy the message flow, we can try out these extra few nodes that we've got going through the message flow. And that will require us to create a new issue in GitHub to trigger the workflow a second time around. So I'll be a little bit more brief this time around. So I'm going to call this one another excellent issue and a very short description field here. And once that's been created, we'll trigger the flow a second time around. And this time, not only will we see the prior outputs, but we should also be able to dig into the actions of what the trace node and what the compute node have done for us. So again, we can go back into the flow exerciser. We need to wait for up to a minute for the flow to be triggered. And it's come through, so we can now see the blue line going beyond the Slack request node into the last 3 nodes of the flow as well. And if we examine the file system, we'll notice we've got a trace file and the output text file from the flow. In the trace file, we start with the traditional trace of the output routes, which includes a JSON domain structure. But then more interesting is when we start looking at the context tree shown on screen, where inside the nodes section, we have a GitHub input from the beginning of the flow. And then when we scroll a little bit further down, we can see that the title information and the body description have come through as part of that info from Git. And then scrolling further down, we then have the Jira request entries. And the payload there has the Jira issue ID, the internal ID of 10135. And at the bottom here, we have the Slack request node entries as well. So this is in one trace file, the entries from all of the 3 prior nodes that have all been carried through with the context. And this is the output file, and we have the Git issue number, the Jira issue number that have been carried forward as well. And that concludes our demonstration, other than maybe the final job, which is to go off and check that the flow was still successful and see that the compute node hasn't damaged anything else there. And sure enough, if we go back into Jira and do a refresh, we should see that not only is the fabulous demonstration issue there, but also another excellent issue has come through too. And that concludes the example of using context trees as part of your toolkit flow development.